Yeah, well, Betsy gets that loaded up. So, yeah, you might have noticed it's a 5-minute presentation. I already speak pretty fast, so hold on. But really, what Inga and I want to do is just give you the essence of an experiment that we did this growing season at the Mount Vernon Research and Extension Center, looking at the impact of different nitrogen rates on nematode parasitism in red raspberry. So just to kind of set the stage, many of you know this organism. This is Pratylenchus penetrans, or root lesion nematode. It's a migratory endoparasite. It spends part of its life in the roots, feeding of raspberry, and part of its life living in the soil. And when we have surveyed growers here up in Whatcom County, this is the primary organism that you guys cite as to why you are engaging in pre-plant fumigation. And what we're looking at here is an image that was taken from a study that Tom Walters and Inga Zazada did a few years ago, looking at Cascade Bounty and Mika raspberry in both fumigated and non-fumigated plots. And really what I wanted to highlight is the severity that root lesion nematode parasitism can have on plant growth and development in red raspberry. So you see at the top, our non-fumigated plants are really not thrifty, poor vigor, poor growth, and our fumigated plants are growing much better. So pre-plant fumigation is a really important tool to help your plants get growing when there's high levels of nematode populations in your field. Why is there skips? How about, I've got 5 minutes, Daryl, so maybe we can address that a little bit later, but thank you for your curiosities. All right, so most growers are engaging in pre-plant fumigation, and as you know, there are really few post-plant management options. We have Vidate, and that has many limitations that you know of. And so what Inga and I are looking at are what are some options post-plant that we can have to kind of add to the toolkit for growers if you say, if you have not a very good fumigation, or you have such high death thresholds that you want to try to help manage the parasitism in your field. And so one thing that we thought about was how fertility might have a role in enabling plants to kind of compensate for parasitism in a field. And this question really kind of came from going to different raspberry sites here in Whatcom County, seeing good vigor, good productivity, but when we sample and we look at the roots in the soil, we see really high populations of root lesion nematode, sometimes 3,000, 5,000 p penetrans per gram of root, but the plants still look fine. So these are also fields that are, highly manicured, have good high input systems. So again, we're wondering, what role does fertility play in this? And so what we decided to do was to focus on the component of nitrogen in an experiment that we did this year, and really wanted to look at how different nitrogen rates during red raspberry establishment influences shoot growth, root growth, root lesion nematode population densities, and the subsequent damage that we see to plants. So we established this at the Mount Vernon Research and Extension Center. We have 100 microplots there, so they're individual plots, and we planted 1 tissue culture meeker per plot, and we had 5 treatments, so about 20 plants received each treatment. And we had these following treatments here. So kind of as a control, we had 0 pounds of nitrogen per acre plus inoculation with root lesion nematode. And then we looked at 30, 60, and 100 pounds of nitrogen per acre rate. And these 30 and 60 rates kind of came from the OSU guidelines that are recommended up here. And then 100 was really just to kind of see if we push that rate, what do we observe? And then we also had a control where we had 60 pounds of nitrogen per acre without root lesion nematode inoculation. So here's what the field experiment looked like when we went through and collected shoot biomass data. And this was the experiment, what it looked, basically the experimental treatments and how the treatments were dispersed across the field. And so here's what we found. I'm just going to focus on a few variables that give the essence of what we observed this year. So this is primocane height. I apologize, it's in centimeters, but if you want to convert to standard units, 1 inch is 2.5 centimeters. So we started collecting monthly height data of the primocanes in June, and what you see is that in June we didn't see any significant differences in plant height, but starting in July we do see differences where we're getting the lowest shoot growth at our 0 pounds of nitrogen per acre rate with inoculation, and our highest was at our 60 pounds of nitrogen per acre rate without inoculation. And then the remaining treatments were statistically the same. And this trend held throughout the course of the experiment for this year. And then here what we're looking at is shoot biomass, as well as populations of root lesion nematode in the soil and roots. So the shoot biomass, again, followed the same trend. We observed more growth at the 60 pounds of nitrogen per acre rate without inoculation, the less at the 0 pounds of nitrogen per acre rate with inoculation, and then the remaining treatments were somewhere in between. It was a little interesting at the 100 pounds of nitrogen per acre rate with inoculation. It had more similarities to the 0 pound per nitrogen acre rate with inoculation than some of the others. And then just to show that our inoculation was effective, our non-inoculated plots had essentially 0 nematodes, whereas the inoculated plots were statistically the same in terms of their population densities of nematode. So we were successful in getting inoculation. So the take-home messages from this experiment for this year is that plants treated at the 60 pounds per nitrogen per acre rate without root lesion nematodes were growing the tallest. They were the most thriftiest, while those treated without nitrogen with nematodes were the shortest. And shoot biomass followed a similar trend. Really what this tells us too, when we look at some of the other rates that we evaluated, the 30, 60, and 100 with root lesion nematode inoculation, is that those higher rates of nitrogen really did not compensate for that parasitism. We're planning to collect yield data from this in 2018. I also want to underscore that there's still, as you know, a need for more post-plant management options for root lesion nematode. And then last, I just want to thank the Washington Red Raspberry Commission for funding this project. So I don't know if I have time for questions.
I have a short one.
Okay, Daryl.
Surprise. When you're talking about the nitrogen, are you dipping the plants, or are you putting the fertilizer on ahead of time, or kind of during the growing season?
Sure, excellent question. Yep. So what we did was we applied about 10% pre-plant of the total amount that we were going to apply, and then the rest that we applied was through weekly liquid applications, and we used urea mixed in water. Does that help? And we applied, around mid-May through mid-July is when we applied our treatments of liquid.
And what do you mean by my naivety? The inoculated nitrogen, what do you mean by that?
Oh, yep, the question was inoculated. So we're looking at 2 different variables, nitrogen and root lesion nematode parasitism. So we had, when we talk about inoculation, we had basically roots of raspberry that had nematodes in them, and we basically weighed and standardized and applied them into the microplot as we were planting the plant to ensure that we had nematodes present in the soil that could impose the parasitism that we wanted to look at. So, all right, thanks.
Great. Thanks,
I think
Lisa.
I'm done. Thank you.
Yeah. All right, we've got